Welcome. Today we're diving into the fascinating world of generative AI. This video will answer the top 20 questions everyone has about Gen AI, from its basic definition to the latest trends and concepts. Whether you're a beginner or just curious, you'll find clear explanations and practical insights here. Let's start by understanding what generative AI is and why it's making headlines across industries. Ready to explore how machines can create, imagine, and innovate? Let's get started with the basics and build up to more advanced topics as we go. Generative AI refers to artificial intelligence systems designed to create new content, such as text, images, music, or even code. Unlike traditional AI, which focuses on recognizing patterns or making predictions, generative AI can produce original outputs that mimic human creativity. These models learn from vast datasets and use that knowledge to generate content that's coherent and contextually relevant. Think of tools like ChatGPT or DALL-E, they're all powered by generative AI. This technology is revolutionizing how we interact with machines and opening up new possibilities in creativity and automation. Oh, how does generative AI differ from traditional AI? Traditional AI systems are typically designed for tasks like classification, detection, or prediction. They analyze data and provide outputs based on learned patterns. Generative AI, on the other hand, goes a step further by generating entirely new data. For example, while traditional AI might identify objects in a photo, generative AI could create a brand new image from scratch. This distinction is crucial for understanding the unique capabilities and applications of generative AI in today's world. Generative AI systems are built from several key components. These include neural networks, large datasets, and advanced algorithms that enable learning and creativity. Neural networks, inspired by the human brain, process information in layers and learn complex patterns. Training data provides the foundation for these models to understand language, images, or sounds. Algorithms like transformers and attention mechanisms help models focus on relevant information and generate high-quality outputs. Together, these components form the backbone of modern generative AI. Prompt engineering is a crucial skill in working with generative AI. It involves crafting effective prompts or instructions to guide AI models in producing the desired output. The way you phrase a prompt can significantly impact the quality and relevance of the AI's response. For example, asking a model to write a poem about the ocean versus describe the ocean in 3 sentences will yield very different results. Mastering prompt engineering allows users to unlock the full potential of generative AI tools. Temperature and top K are parameters that control how generative AI models produce text. Temperature determines the randomness of the output. A higher value leads to more creative, varied responses, while a lower value makes the output more focused and predictable. Top K limits the number of possible next words the model can choose from, balancing creativity and coherence. Adjusting these settings helps users fine-tune the AI's behavior, making it more suitable for different tasks and audiences. Embeddings are a way for AI models to represent words, images, or other data as numerical vectors. These vectors capture the meaning and relationships between different pieces of information, allowing the AI to understand context and similarity. For example, the words king and queen have similar embeddings because they share related meanings. Embeddings are fundamental to how generative AI models process and generate content, enabling them to work with complex data efficiently. Foundation models are large, pre-trained AI models that serve as the starting point for a wide range of applications. These models are trained on massive datasets and can be fine-tuned for specific tasks, such as language translation or image generation. Examples include GPT-4 and BERT. Foundation models provide a flexible base, allowing developers to build powerful AI systems without starting from scratch. Their versatility and scalability have made them a cornerstone of modern generative AI. Multimodal AI refers to systems that can process and generate multiple types of data, such as text, images, audio, and video. Unlike traditional models that focus on a single data type, multimodal AI can understand and combine information from different sources. For example, a multimodal AI might generate a caption for an image or answer questions about a video. This capability makes AI more versatile and better suited for real-world applications where information comes in many forms. Transformers have largely replaced older models like RNNs and LSTMs in generative AI. RNNs and LSTMs process data sequentially, which can be slow and struggle with long-range dependencies. Transformers, however, use attention mechanisms to process all input data at once, making them faster and more effective at capturing complex relationships. This shift has enabled breakthroughs in language modeling, translation, and content generation, powering today's most advanced AI systems. Attention mechanism is a core innovation in modern AI models. It allows the model to focus on the most relevant parts of the input when generating output. For example, when translating a sentence, the model pays more attention to words that are important for meaning. This mechanism improves the quality and coherence of generated content, making AI more accurate and context-aware. Attention is a key reason why transformers outperform older models in many tasks. Encoder and decoder models are fundamental building blocks in generative AI. The encoder processes input data, such as a sentence or image, and converts it into a numerical representation. The decoder then takes this representation and generates the desired output, like a translation or summary. This architecture is used in many applications, from language translation to image captioning. Understanding how encoders and decoders work helps explain the inner workings of generative AI. Reinforcement learning from human feedback, or RLHF, is a technique where AI models learn from human preferences and corrections. Instead of relying solely on data, the model receives feedback from people, helping it improve its responses and align with human values. RLHF is especially important for generative AI, ensuring that outputs are not only accurate but also ethical and user-friendly. This approach bridges the gap between machine learning and real-world expectation. Retrieval Augmented Generation, or RAG, combines generative AI with information retrieval. The model first searches for relevant documents or data, then uses that information to generate more accurate and informed responses. This approach is especially useful for tasks like question answering, where up-to-date and factual information is crucial. RAG enhances the capabilities of generative AI by grounding its outputs in real-world knowledge. Hallucination in AI refers to situations where a generative model produces outputs that are plausible sounding but factually incorrect or entirely made up. This can happen when the model lacks sufficient information or misinterprets the prompt. Hallucinations are a significant challenge in AI, especially for applications that require accuracy and reliability. Understanding this phenomenon is key to using generative AI responsibly and effectively. Reducing hallucination in generative AI involves several strategies. These include improving training data quality, using retrieval-augmented methods, and incorporating human feedback. Regular evaluation and fine-tuning also help ensure that the model produces accurate and trustworthy outputs. By addressing hallucination, developers can build AI systems that are more reliable and better suited for real-world use cases. AI agent is a system that can perceive its environment, make decisions, and take action to achieve specific goals. In generative AI, agents can interact with users, perform tasks, and even learn from experience. For example, a chatbot that answers questions or a virtual assistant that schedules meetings are both AI agents. These systems are becoming increasingly sophisticated, enabling more natural and helpful interactions between humans and machines. Zero-shot and few-shot prompting are techniques for guiding generative AI models. In zero-shot prompting, the model is given a task without any examples, relying solely on its training. Few-shot prompting provides a few examples to help the model understand the desired output. Few-shot prompts usually lead to better performance, especially for complex or unfamiliar tasks. Knowing when to use each approach can make your interactions with AI more effective. Chain-of-thought prompting is a method that encourages AI models to explain their reasoning step by step. Instead of jumping straight to an answer, the model outlines its thought process, making the output more transparent and understandable. This approach is especially useful for complex problems, as it helps users follow the logic behind the AI's responses. Chain-of-thought prompting is a powerful tool for improving both accuracy and trust in generative AI. Large language models, LLMs, and small language models, SLMs, differ mainly in size and capability. LLMs like GPT-4 have billions of parameters and can handle complex tasks with high accuracy. SLMs are smaller, faster, and require less computational power, making them suitable for lightweight applications. The choice between LLMs and SLMs depends on the specific needs of the task, balancing performance, speed, and resource requirement. Generative AI is already transforming industries, from creative arts to customer service and beyond. As models become more advanced, we can expect even greater innovation in how machines assist, create, and collaborate with humans. The future of generative AI holds exciting possibilities, but also challenges around ethics, reliability, and responsible use. Staying informed and understanding these core concepts will help you navigate and make the most of this rapidly evolving technology.